Hello everyone. In this video, I'm going to be covering laws of indices, and this is just a precursor to starting a series on Cal 1. And there are some people who take Cal 1 and they say that they can't seem to pass it, can't understand it. It's probably because they don't have a good foundation. And one of those foundations is covering this topic here, understanding this here, laws of indices, or something called law of power, exponents, or whatever. They're all the same. So you have to know that if you're multiplying um, two factors with the same base, say x to the y times x to the z, you have to be able to know that you can um, equate it to x equal to y plus z. So this is something that has already been proven. If you want to go and find the proofs, I'm sure you can find it and you know do some more in-depth study about these functions and how they relate to each other. But as they are, you just have to know them. So if you multiply these two together, their exponents gets added. And here, if you have something raised to a power of something, and then you're multiplying it outside of the bracket, it just becomes y. In this case, it just becomes y times z or yz. They're the same. You just have to know that this and this are the same. And here, you have to know that when you open the bracket, that x carries the z as well as the y. You're not just going to open the bracket and write x y z, and that would be wrong. The x has to carry the same thing too. So here, x is equal to raise the reciprocal of a, and that means you take the square root of x with respect to a. And it could be anything. And if this is x raised to the 2, then you're just going to be taking the square root of x. If it's x raised to the third, then you're going to be taking the cube root of x. And here, you're taking the nth root of x and y, and you have to be able to know that you can separate these two if you want to, or if you see them like this, you can rewrite it like this. And this is another important one. I think 1, 4, and 6. Number 7 is 2. Number 9 are one of the most important ones, especially 1 and 6. You get to use that a lot. You have to know that. Number 7 as well. So if you see a division with the same base, you should be able to know that you can take just one of those and then subtract the exponents. And here, whenever you have something raised to the power of negative something, that negative can be written as a reciprocal of that function or factor. And here's x divided by y raised to the n, and of course you should know that when you open the brackets, it's going to be x to the n divided by y to the n. That one's kind of plain. This one is not so obvious, but it's kind of similar to 4. This value down here always does a root. It's a root of whatever is raised to, and this is the power. This would, it's a multiplier, while this one would take a give you the root of this number. So essentially, you should be able to know that when you rewrite this, you can write this as this, or if you have this form, you should be able to know you can write it like this, and this as well. So just look over this, make sure you understand it, and Guess we should just do a quick examples, and we're done with this video. Then we're going to start Cal 1. Okay, let's look at these examples. I'd advise you to just pause it here and try to solve them, and then look to see if you have the right answer. They're not just single laws. Some of them I combine them. So let's just test our knowledge here on a law of indices. So this one is x times x to the 2 times x to the 1 over 2. And we know from the law that we can combine the x and then add the exponents. Plus 1 over 2. And then we do this here. The lowest common denominator. There's a 1 here. Well, I'll explain this. It's in the fractions video. So, okay, that will make it 4 plus 1. This is equal to x to the 5 over 2. And this one here, we know that this would be x to the 2 divided by 3. But then we're not done yet. This then is equal to the cube root of x raised to the power of 2. So that's it. It's acceptable, depending on what kind of problem you're doing, to leave your answer like this as opposed to this here. You do this only if you can solve it further. If you can't, just leave it as this. You just need to be able to know that this will give you this. And here, we're just going to get, we know that we're going to be multiplying these two together. We're not adding because there's not another x to go from. So this is just going to be x to the negative 4, which would then be a reciprocal of x to the 4. So that's what you get there. And here we have x cubed divided by x squared. You should be able to know that x to the, this is the same thing as x to the 3 minus 2. See, here we're multiplying and we're adding the exponents. Here we're dividing and we're subtracting the exponents. So you should know that. And when you subtract 2 from 3, it's going to have x to the 1, which is not really what we're adding. That just makes it equal to x. So this one here, you just need to know that this is the same thing as 4 to the root of 4, x to the 4th power times the same for y. And you should be able to know that you can also rewrite these as x to the 1 over 4 times y to the 1 over 4. Or you can combine them if you want. They're all the same, but just to know that it is the same. Once you know it, then we're pretty much in business. So that's it for the laws of indices, and we're going to go into Cal 1. Thank you for watching. Have a wonderful day.